Hey everyone, this is Mrs. Hilt with your lesson on counting atoms and balancing chemical reactions. All right, chemical symbols. When you look at a periodic table, like the one shown right here, you are looking at all of the different elements on the periodic table represented by their chemical symbols. We have these chemical symbols so that when we write out chemical formulas, we're not having to write out all or the whole name of the element. It's kind of like how we have initials for our first, middle, and last name. Elements have initials just to shorten it, make it easier. And when elements are represented in a compound, we use those chemical symbols to identify the different types of atoms. All right, the first letter is always capitalized, and if there only is one letter, then that is capitalized. The second letter always has to be lowercase so that we can distinguish when a new atom is present in a chemical compound. So for example, CaCO3, we have a calcium atom, uppercase C, lowercase a. We have a carbon atom, just a capital C, and an oxygen atom, just an uppercase O. And whenever you see these subscripts, like this little 3 right here, that tells you how many atoms of whatever element it follows there are in that compound. So here, since there is no number after calcium, we just have 1. Since there's no number after carbon, there is just 1. Because there is a 3 after oxygen, we will have 3 oxygens in this calcium carbonate compound. Oops. All right, so counting atoms. We already had an example just on that last side with the calcium carbonate, CaCO3. But how we go about counting up all the atoms in a molecule is just by counting how many times you see that chemical symbol in the formula and multiplying it by any of the subscripts that you see. So I see carbon 1, 2, 3, 4, 5 times. There are 5 carbons. And for hydrogen, there is 3 plus 2 plus 2 plus 2 plus 3 to give us 12. Sometimes molecules will look a little different and not be as spread out like the last one. And in that case, compounds will use parentheses. And to add up the number of individual atoms when you see the parentheses, you go about this the same way that you do in math class with distributing. So for this problem, I have 3 calcium atoms. And to identify the number or add up the number of P or phosphorus, I distribute the 2 through. So I have 2 phosphorus atoms. And I will distribute the 2 to oxygen as well. And it'll be 2 times 4 to give me 8 oxygen atoms. All right. So let's start off looking at the 2CO2. So when you have compounds in a chemical reaction, you will need to balance out that chemical reaction so that there are the same number of atoms on either side of the reaction. We'll get into more of that later. But you will need to balance out those atoms by using coefficients like this big 2. And whenever you see a big number or big coefficient in front of a compound, that tells you that there are however many that number is of that compound. So this tells us that we have 2 molecules of carbon dioxide. And again, the little subscript tells us the individual number of atoms in that compound. And we can use all of these different numbers to add up the total number of individual atoms. So let's get some practice with ammonia. If you want to try this on your own first, pause the video, and when you're ready for the answers, press play. All right, let's walk through this. Okay, how many molecules of ammonia are there? There are 4 molecules of ammonia because we have a coefficient of 4. What element is represented by the symbol N? If we looked at a periodic table and find N, we would see that that is nitrogen. Oops. My E kind of got lost there. All right, what element is represented by the symbol H? Again, look at your periodic table, find H, and you will find hydrogen. All right, how many atoms of N are there in a molecule of ammonia? So there is no subscript after N, but simply because there is an N there, we know that there is at least 1. So there is 1 nitrogen atom in a molecule of ammonia. And this 3 tells us there are 3 hydrogens. All right, now in 4 molecules of ammonia, we're going to do some multiplication. If we have 4 molecules of ammonia and each of those has 1 atom of nitrogen, we have 4 atoms of nitrogen. And we'll do 4 times 3 to get the total number of hydrogens, which is 12. All right, let's go through some examples. Now, if you're feeling confident, I want you to pause the video and try answering these 3 questions on your own. When you're ready for the answers, press play. All right, let's give these a try. How many different atoms are in NaHCO3? Well, there is a sodium atom, there is a hydrogen atom, there's a carbon atom, and there are oxygen atoms. So that tells us that there are 1, 2, 3, 4 different types of atoms in that compound. All right, now identify which of the following chemical formulas are the same. So in order to do this, we need to add up the total number of atoms the total number of each different atom in the formulas. So the first one looks like there are 2 carbons, and there are 4 hydrogens, and 2 oxygens. Then next one, we have 2 carbons, 4 hydrogens, and 2 oxygens. Next one, 2 carbons, 4 hydrogens, 2 oxygens. And the last one, I can already see that it is different than those first 3. So the ones that have the same number of atoms are the first 3, and the same type of atoms as well. All right. Write the chemical formula for the compound shown to the right. So we are going to do this very similar to how we just counted up the atoms in the second problem. So we're going to start with carbon. I see 1, 2, 3, 4, 5. So C5. Then let's do hydrogen. 1, 2, 3, 4, 5 hydrogens. Now nitrogen, there's 1, 2, 3, 4, 5 nitrogens. Now there are other rules that go with writing formulas, and that goes with like which type of elements come first and the order that you write them in, or like why sometimes you may have the atoms written out instead of all condensed. There are other rules for that. However, right now, I just want you guys to focus on counting the atoms and knowing how to write out the formulas based on just the total number of atoms in the problem. All right, now some more practice. So for each of these, I want you to determine the number of unique atoms or the total number of different atoms in each molecule. So pause the video. When you're ready for the answers, press play. All right, let's check your answers. All right, again, pause the video and check your answers with mine. All right, moving on. All right, now that we know how to count the number of atoms in individual molecules, we are ready to start balancing chemical reactions. And the biggest thing to keep in mind when you are balancing chemical reactions is that you always have to follow the law of conservation of mass, which tells us that matter can never be created or destroyed. It can be rearranged, however. So what this tells us, or why we balance equations, is so that we can have the same number of atoms on either side of the reaction. Because if a carbon atom will always weigh the same as any other carbon atom, no matter what form it's in. So we need to have the same mass totals on either side of the reaction for that reaction to be true. How a chemical reaction looks is we have the reactants on one side, an arrow pointing towards the products. The reactants are the species present before the reaction, and those will get rearranged and produce a product. The arrow always means yields or reacts with or to produce. Here are some chemical symbols that you guys might see. We got an arrow. There's also a double-sided arrow, which just means that reaction is reversible. And some of the more common ones you guys will see specifically in this class are this S in parentheses, which means solid, an L, which means a liquid, G, gas, and this AQ, which means aqueous. It just means that substance is dissolved in water. Okay, so getting into the balancing of chemical reactions. Here's an example of a balanced chemical reaction, meaning that it has the same number of each type of atom on both sides of the reaction. And we balance them with these things called coefficients. So the 2 and this other 2. Here's how it looks if we were to draw it out atom by atom. So draw a little arrow here. Think of the arrow, the reaction arrow, as as the center of a seesaw. Sorry, and on either side of the seesaw, we want it to be balanced, so that's completely flat. So that means we have to have the same amount of mass on either side of the seesaw. We do in this reaction because we have 2 oxygen atoms on the left side, 2 oxygen atoms on the right side, so they balance out. We have the same with hydrogen. We have 4 over here and 4 over here. So now with balancing equations, it is a little bit more tricky than just adding atoms on either side. You have to keep the reaction true. So I can't just randomly add more hydrogen atoms over here and some more hydrogen atoms over here. I have to keep true to the chemical reaction or the chemical equation. So I can only add hydrogen in the form of an H2. I can only add oxygen on this side in the form of an O2. And I can only add water on this side in the form of H2O. Oops, went a little too fast. And when you're going about balancing, the only thing that you can change is the coefficient. You can't change the subscript because that would be changing the chemical equation. Got a little joke here. Let you guys pause the video and read that. All right, so balancing chemical equations. I'll let you guys pause the video and read through this. I'm going to go ahead and get to the visual examples. Same thing. Pause the video, check this out. When you're ready for the visual examples, press play. All right, so this is an example of something that you guys would see if you were asked or when you were asked to balance a chemical equation. We leave these spots in front of the numbers just so that we can write in a coefficient. And we got plenty of space down here to balance it out. So what I like to do, and I highly recommend doing something similar to this when you guys are starting off, is to make it organized for yourself. All right, so for this example, when you balance these out, I highly recommend using some format like this. My center of the seesaw is right here, and I need to have the same number of each type of atom on both sides. Okay. And I suggest choosing one atom and balancing it until it is balanced, then move on to a different one. And I also recommend leaving elements that are by themselves, like carbon here, to balance until the very end, because if I need to add more carbon atoms, I can without throwing off the number of atoms of a different element. Okay. Notability makes this really nice and easy. All right, so let's start with cobalt. So CO, my orange dots, on the left side of the reaction, I have 2. On the right side, I have 1. So I have to add another cobalt on this side. I'm going to duplicate that. All right, my cobalt is balanced. Now let's move on to oxygen. So on the left side of the reaction, I have 3 oxygen atoms. On the right, I have 2. So I'm going to need to add more oxygen atoms on the right side, but I can only do it by adding a whole another compound. So I'm going to duplicate that. All right, now I have 4 oxygen atoms and 3 on the other side. Okay, so again, can only add oxygen on this side of the reaction by adding a whole another compound. So I'll duplicate that. Now I have 6 oxygen atoms and 4 on my right side. Go back again and duplicate it again. All right, now my oxygen is balanced by adding 2 more, so a total of 3 carbon dioxides on this side of the reaction, and by adding a second CO2O3 on this side of the reaction, I was able to balance my oxygens. In that process, I did end up unbalancing my cobalts, but that's easy to go back and add 2 more. Duplicate those. All right, now cobalt is balanced. The only one left is carbon, and I have 3 total on this side, so that means I need to add 2 more. All right, so now let's write in our coefficients. There are 2 compounds of CO2O3. There's 1, 2, 3 C's, 1, 2, 3, 4 COs, and 1, 2, 3 CO2s. All right, you guys will have some practice of your own, and this is actually going to count as a quiz grade. You can attempt this as many times as you need to, but we need to get a total of 10 equations balanced correctly, and then you get a quiz grade of a 10 out of 10. Let me know if you guys have any questions.